So, I don't know if any of you guys know, but I tried to stream just earlier, yeah? And internet wasn't working, obviously. Well, I say obviously, but half of you might not have seen it. So let me tell you what happened. So basically, my mum's just got an email now from our internet company. I'm not going to say what or anything, because you never know. But they've said that today they've had a global issue with the internet connecting to certain websites and things. And guess what? The internet's working fine now, I think. I hope it's working fine. But yeah, that means I can turn my ring light on, Oliver. Cheers. And that means we can get back to streaming. Because that was a bummer, because I thought I wouldn't be able to stream today. Even though I did stream this morning, but I want to stream again! Anyway, I was saying earlier, I've got some educating to do, so now hopefully I can get my stream up on the tablet. Couldn't do that before, you see. Subscription. How many? E F G H I J K L M N O P. Oh, there I am. Yay! Yeah, we're back. I think we're back. Yeah, we back. We good. We back. Damn. We're back. Right. Let's zoom in again. Because, yeah. We're back! Sorry about that though, but guys, by the way. I do apologise. And yeah, my face camera's a bit laggy actually. I'll be honest. But it's probably the aftermath of the internet stuff, so excuse that. Anyway, I need to get my science homework up. Hold on. You guys can help me with my science homework, even though none of you are here, but you guys can watch me do it. But I'm not going to show you my login obviously because I think it shows my school, so I'm going to wait until it doesn't show my school. It shouldn't show my school while I'm answering the questions. What? Oh. There we go. Yeah. Okay, I've got one quiz to do. Yeah, I think I can show now. Okay. Need help with guys. So, a solution of potassium hydride. What the fuck? A solution of potassium hydroxide was titrated against a solution of hydrochloric acid. How many moles of potassium hydroxide would react with 1 mole of hydrochloric acid? What? Write out a bang of simple equation for the reaction. Okay, listen it. 1 mole. 2. Okay. We use the table to work out the mass in grams of 1 mole of water. The mass. 1 mole of water. H2O. So there's 2 hydrogens. 2, 18. Yeah! 124 grams of magnesium that was heated in the air. 40 grams of magnesium. What mass of magnesium would be needed in order to produce 10? What? What grams of magnesium? Okay, so to produce 10 grams, so we'll just divide that by 4, 6. Hey! Look how good we are. Wait, what does it say? Yeah. That's what I thought. Right. A solution of sodium hydroxide, which I think is that, was added to a solution of sulfuric acid, which might be that. How many moles of sodium hydroxide would react with 1 mole of sulfur? What? 1. 1, 2. Of course it is. Chemistry's so difficult. I hate chemistry. Right. The relative molecular mass of sodium hydroxide is 40. If we see grams of sodium hydroxide out in soda and water, how many moles will be in a solution? Right, so the relative molecular mass of sodium hydroxide is 40, but if 60 grams of sodium hydroxide are dissolved in water, how many moles will there be in the solution? 2. What do they do? 60 divided by 4. Oh, of course. Which is greater, the mass of 1 mole of carbon or the mass of 1 mole of iron? I think the mass of 1 mole of iron. Yeah. What is the missing word? 1 gram of a substance contains the same amount of molecules as in 12 grams of carbon. Wait, one more. Show links. Okay. They've recommended this. Let's have a look at this. Moles are used to measure amount of a substance. That's right. Okay, yes, I've just read that. 1 mole always contains 6.02. Okay, yep. Should we just go next slide? Show all lines, yeah. Next slide. Right, so what do we need to look at right now? Okay. Right. Doesn't change. The constant doesn't change. Oh, look, Avogadro. The Avogadro mole. I thought it was a mole, but I didn't want to say it. What mass of carbon dioxide? So that's carbon and oxygen. No, carbon times 2, so that's 32. We're using a reaction assuming complete combustion. Okay, hold on. So 48 grams of butane. 32 plus 12. What the hell? Okay, so CH4. Where have you got CH4 from? Yeah, actually, yeah. Where have you got CH4 from? Huh? Tell me! Where have you got CH4 from? Where have you got it from? Where you got CH4? Is that methane? Okay. Hold on. What element of CH? Sorry. I know, yeah, actually, yeah, I know, let's look at this. What symbol is CH? No, yeah, CH. No, what symbol is methane? Oh, it's a compound. So that's where they've got that from. That makes more sense now. I could have been told that information. You know what? For this, I need a bloody periodic table up. Hold on. Let me get a periodic table up. There we go. No, I want high resolution on them. Here's what we can do. We can go. Oh no, we can't. Tools, size, large. Actually, no. Let's go Microsoft Bing. Microsoft Bing's good at this. Microsoft Bing's good at this stuff. So let's go back. Let's do periodic table. Go to images, filter, image size, large. Bam. That's blurry. That's not large. You. Open image in new tab. There we go. This is what I'm talking about. Right. So, okay, that's the periodic table. The periodic table. Yeah, just in case we need that. Just in case we need that. Oh, upstream. Okay, so, yeah, methane. That's obviously 16, yeah. Moles of methane. Mass, which is the mass is 48. So, 48 divided by 16 is 3. Yeah. Yeah. Okay. So, okay, look at that. So, 3 moles. The ratio of CO4 to CO2 is 1:1. Why? So 3 moles of carbon will react with 3 moles of methane, and then 12 plus 2 times 44. How the hell do you go for? Yeah, that's what I did. Actually, I got 44. Yeah. Oh no, but then you times it by 3. Oh wow. Oh, okay. That's confusing to me. It's really confusing. Alright, continue guys recommending these study guides. So I've got the study guide. They're not helping! A container holds. I'm assuming. A container holds. Actually, let's reduce contracts. Let's make it a bit like that. No. Oh yeah, what do we have here? Ooh. Oh, we could have that. Dark mode. Coming soon. What do we want? What did we have before? We'll just font size large, please. Oh, they're coming soon. I've got to say, well, John, do you add that then? Okay, peach. Yeah, let's do peach. No, let's not do peach. That yellow. Oh, Jesus Christ, they're all really bad. Cyan. Alright, a container holds 4 grams of high. Okay, a container holds, hide score, hide links. Let's just go. A container holds 4 grams of hydrogen gas. How many moles of the gas does it contain? You may want to use a table below to help you. So a container holds 4 grams of hydrogen gas. So if it's 4 grams, 4. How many moles of the gas does it contain? 4, 2. Oh my god! I just guessed. I just guessed. That's crazy. That I just guessed. Oh, it's because hydrogen gas is represented by H2. And then you do 4 times. Yeah, that makes sense. All right. There's only a bit more to this. Right, let's go. So, a solution of potassium hydroxide. Actually, my face cam's probably covering a lot of it, actually. Let me move that real quick. There we go. Let's go. A solution of potassium hydroxide, KOH, is added to a solution of does this help? No. Hydrochloric acid. How many moles of potassium hydroxide would react? Lucas said. That just reacted. Would react with 1 mole of hydrochloric acid. May have the right balance the symbol equation for the reaction. So it's 1. Is that right? Yay! Actually, I'm going to zoom out a bit, bro. I'll be honest, but we got to keep it up because our face cam's probably up here. Of sodium hydroxide would be needed in order to make 50 grams of sodium sulfate. Give your answer to 1 decimal place. What I'm going to do 80 grams of sodium hydroxide reacts with excess sulfuric acid to produce 142 sodium sulfate. Okay. I think I get where they got that from. So they've added on 42 more grams. Yeah. No, 62 more grams. What mass of sodium hydroxide would be needed in order to make 50 grams of sodium sulfate? Ooh, so we'll just do 142 divided by 80, right? And that is... So if we do 142 divided by 80... Am I allowed to use a calculator for this, bro? Am I allowed to use a calculator? I'm using a calculator anyway. Calculator. 142 divided by 80. 1.775. So you're telling me we need 1. How the black. Okay, so keep these numbers in mind. So 2. The MR. Oh my days. Oh my days. 2 times, okay. So we need to find the moles of them. So that's 142. Oh no, let's try doing that first. 142. Yeah. Sodium sulfate. 0.3 more because we divided the other way. Alright. Then the ratio is 2 to 3, so the moles of hydroxide needed times 2 equals 7 moles. Yeah. The MR of sodium hydroxide, 23 plus 16 plus 1 is 40. So the mass of hydroxide is that times that don't really make sense to me, but sure, go for it. Which contains more molecules? 1 mole of water or 1 mole of methane? I'm gonna go with this because I have 4. Okay, so 1 mole is always the same number of... Oh! It literally said that earlier. Look at the equation below. CaCO3, CaO, CO2. I've looked at it. Look at the equation below. When calcium carbonate is heated, it decomposes to produce calcium oxide and carbon dioxide, as shown in the diagram below. How many grams of carbon dioxide would be made in this reaction if 4 grams of calcium carbonate are used? Right, so if 4 grams of calcium carbonate is used, how many grams of carbon dioxide... Why did it phrase like that? How many grams of carbon dioxide will be made? Okay. So calcium carbonate, I think, is that. I could be wrong. Let's look at. So what we're gonna do? Let's find out calcium carbonate. Let's find out what symbol calcium carbonate is. CaSO3. Okay. So now we found out that's calcium carbonate. So if 4 grams of that is used, how many grams of carbon dioxide will be made? That's carbon dioxide, obviously. That's carbon. No wait, what's CO? What is CO? Wait, what was it? No, CaO. CaO. Calcium oxide. Okay. Oh, it does say that. Calcium oxide. Okay. Let's see if this thing will help tell us anything. Let's zoom out for this. Next slide, please. I don't know. Ooh. Okay, yeah, show me some of this. No, not what I want. No. Oh, that's it. Right, go back to slide 1. Nope. I don't think that's helping us. Right, so 4 grams. 4. The MR of that is 100, okay, so 100 moles of calcium, that'd be MR equals 4. Oh, so mass divided by that, and the mass of it is, what's the mass of it? 4. 4 divided by 100 is 0.04, yes. Ratio of CO, how is it that? Why would it be that? Why would it be that? Why would anyone want? Huh? I don't know. How would I supposed to know that? Because the amount of CO2 is 44. So you do 0.04 times 44. Oh my god, this is so confusing, but we've got to work more technical, basically. Work more technical. Work more scientifics. That's what we need to do. Half the whole moles are that's so too technical. Let me check it on. 0.5 moles of calcium carbonate are decomposed by heating. What mass of calcium carbonate is this? You may need some of the information in the table. So what? Okay, so what mass of calcium carbonate? Calcium carbonate in that Ca 40 03. No. Calcium carbonate, let's find out. Actually. Okay, yeah, okay, so CA is 40. CO. No, C. Okay, 40, 52, 48. 52 plus 48. 52 plus 48. Am I stupid? Yes, it's 100. So 100 grams! No, 100 ml. So. Why does it say 0.5? Sorry. One more hours. So I'm a bit sick. Mass about okay. So the mass of it is what? That's what we need to find out. Okay, so if there's wait, we can work backwards. So if there's 0.5 moles. But if you know the mass of something, so what if I know the moles? What is the equation? Okay. What is the equation in chemistry if you already know the amount of moles but need to know mass? Okay, moles times molar mass. What is molar mass? The mass of 1 mole of a substance. What the hell is a molar mass? Right, I need a new thing now. What is molar mass? Mass of 1 mole of a substance. Right, now how do we find out the molar mass? How to find the molar mass? Use the periodic table to get the atomic mass of each element. Atomic mass. Each element atomic mass by the number of atoms in that element in the formula. What? Okay, so we've got all of that, so what did it say? Find the chemical formula. Use the periodic table to get the atomic mass of each. Okay, we have the atomic mass of each thing here. Now you multiply each element by the number of atoms in that element of the formula. The number of atoms of that element in the formula. Okay. Okay. So it's 48. So 24. Right. 24, 24, 24, 24. Let's sit back and relax with this one. Oh. We literally worked out it was 100. We literally worked out 100. Why have I got 48 from? 2.8 grams of silicon react with 3 the value of wine. Oh, sugar. Right, so we will zoom out a bit then. So SiO, why? We need to know the value of Y, so that's how many oxygen we have. Silicon reacts with oxygen. Okay, so 2.8 reacts with that to give a compound, which is shown below. Right, so how are we supposed to know? So relative atomic mass of silicon is 28 and of oxygen is 16. What is the value of Y? Okay, so 2.8 grams. Wait, what? I don't get it. I don't know. So, what? Let's go. What mass of sodium would have been used in this equation? Right. So, okay, the normal equation below shows the reaction between sodium and water. In this reaction, hydrogen gas given off sodium hydroxide is formed. The gas is collected and damage found to be 1.8 grams of hydrogen. What mass of sodium would be used in this equation? How the hell am I supposed to know that? Okay, so hydrogen gas is given off. Sodium hydroxide is formed, and one mass of sodium would have been used in this reaction. I don't bloody know. 3.6. Why would I know that? Why would I have got 41.4? I guess we'll find out. So what about the balanced equation? How will we know the balanced equation if it's no 2 to be seen? To be seen! Okay, so 2Na plus 2H2O. 2Na. Okay, cool. Moles of H2, yeah, 1.8 divided by 2, 0.9. Okay. The ratio of sodium to hydrogen is 2:1. And how would you know that? I'm going to livid. Oh. Well, no, I'm going livid. I'm actually going to do insane. The moles of sodium, 2 times 0.9. So why have we got back to where we came from? Right then, so 1.8, a mass of moles, 1.8 times 23. Hold on a minute. Oh no, hold on a minute. Hold on a minute. Where's my periodic table gone? Here it is. Where's the Na? Where's Na? Na. Oh god, if I don't find an Na, I'm gonna nay. 11. So where have you got? No. 23. So that's where you got 23 from. Okay. Sodium. That's where you got 23 from. And then you times up to the. How would I be able to know that? I'm not some scientist. I'm a kid. What mass of carbon contains? How am I know that? How will I know that? How? This better tell me, man, I swear. Colours and fonts, normal. This better tell me, man, I swear. This better tell me, or else I'm going to go livid. I'm not even joking. I will go livid. 1 mole. Okay, so there's 1 mole. So what mass would that be? Okay, so listen here. So if there's 1 mole in that, to find the mass, it said do mass divided by. Oh yeah, no, but no, it said mass times something. It said mass times something. Okay, so we know the MR. What's MR of carbon? We need the MR of carbon. MR of carbon. That is 12. So it's 12 times 1. I'm so good at this game. It's a game. Let's go. 11 grams. Okay, we need to find the moles already. Good sign. That means moles is mass divided by MR. Let's go. 11 grams divided by MR. Okay, let's go. Carbon dioxide. So carbon dioxide, 32, 42, 48, 44, 44. No, 44. 484. Hold on. No, you wouldn't. No, you did mass. So 11 divided by... Then you calculate right again. So we need 11 divided by 44. 0.25. 0.25. We're getting better. We're learning. This is why we don't cheat. A solution of sodium hydroxide was titrated against a solution of sulfuric acid. How many moles of sodium hydroxide would react with 1 mole of sulfuric acid? Actually, I'm going to change the title. I'm going to change the title of this stream. I might just make the stream a revision stream. I might just change the title of the stream, you know. I'll do that one. That one was a failed attempt. Let's change the title of this to revision. Yeah, come revise and do homework with me. Yeah. Yeah. Sounds a bit better, don't it? Alright. That should have changed now. Yep, the title has changed. Okay, so how many moles of... Okay, so we need moles. 1. Don't even care. I don't even want to read it. Which is great. The number of atoms in 1 mole of calcium and the number of molecules in 1 mole of carbon dioxide. Right, so what I'm thinking is they're the same. Yeah. I'm not getting tricked again. You're not tricking me again like last time. Okay, we need to find the grams. Okay, you've had a mass. The mass divided by the MR. No, the mass times the MR. So 117. So we need calculate the mass of. Okay. So what we need. So we need amount of moles. No, we don't need amount of moles. Okay, we got calculate the sodium hydroxide required. Okay, hold on. How are we gonna find the amount of moles? How to find the amount of moles from the MR? When you find the amount of moles from the, you divide the mass of the substance when you don't have the mass. You don't have the mass. You can't find another mole from mass alone. You also need the mass of the Right, so what I'm thinking, right, guys, is we do. Where am I? Okay, we work out this first. Sodium chloride. We'll do that after. Okay, so sodium chloride, 23. Wait, what's no, don't trick me. What symbol is sodium chloride? Don't trick me. It's sodium. Don't trick me, boy. NaCl. Okay, so there's no extra stuff. 35.5, 23. 58.5. So 58.5 divided by no. 107. No, that don't seem right. That don't seem right. Hold on. 117 divided by 58.5. Oh no, that does sound right. Okay, so 2 moles. Yeah, 2 moles. Okay, 2 moles on there. There's 2 moles on there. So now we got the moles of that. I'm gonna guess there's 2 moles there. So if it's 2 moles there, here's what we're gonna do, guys. We're going to 2 divided by sodium, hydroxide. Okay. So we need Na. So sodium. 23. So we've got 23, and we've got 23, 16. 48, 49. Okay, so 39, we've got 39, and then we need H, 39. 40! We've got 40 of that. So we do 40 divided by 2. So 2 divided by 40. Which way? No. Hold the flipping phone. 2 divided by 40 is not what I think it is, okay? It's not what I think it is. 2 divided by 40 is not 20, is it? No. It's 0.05. Okay, so now that we've got 0.05 for the mass, what we need to do is times it by 100, so it's 5. All that work. Oh, that work. Let's write the balance equation for the, okay, yeah, okay, so, we balance the equation. Okay, so no. Agree. Have you got that? Oh yeah. Nah, I've got H2O. I'd have flip if you got H2O. I don't know where I've got H2O from, but sure. So the MR of sodium chloride. What did I say that was? Yeah, 58.5. Okay, so yeah, we found that. We got that. We got 2 moles of sodium chloride. We got that. So the first step we did right. So therefore 2 moles of hydroxide. Yeah. We got that. 23.6. 40. Yeah. Oh, we divided it. Even though we were supposed to times it. Oh, we were getting so close. Okay, we are getting better. That means we're getting better. This is an improving process. Okay, 6 kilograms of coal is burnt in the air. And coal is carbon. Okay, so 6 kilograms of carbon is burnt in the air. Unless carbon dioxide will be produced, ignoring any periods ago the chemical reaction for this. Okay, so C. So let's go find the milligrammes. So we need kilograms. Which is still a mass, by the way. There's still a mass, I'm pretty sure. Is kilograms still mass? Let's find out. Is kilograms mass in chemistry? Yes. Okay. So the fact that kilograms still mass, that means we need to find an MR. So let's find the moles. Let's find out the moles of carbon. So 12. So 12 times 12. No. 0.5 moles. Okay. 0.5 moles in carbon. So there's 0.5 moles in carbon in O2. We don't know the mass of O2. Do you wanna build a snowman? No! Come on up here again. Right, so there's 0.5 moles in that. It's a ratio 1-to-1. So I think that'll be 0.5 moles in that. So now that we have that, if we do the moles times by 32, so 0.5 times 32, 16. Oh, you got to convert it to bloody grams, and that's a whole other method, though. That's a whole other method. Okay, so we've got to convert it to grams. Okay. So the moles of carbon. I'll drink. Oh, so good that drink. Come on. You guys do not understand how good that drink is. Okay. Oh god. Yeah, 6 kilograms of carbon, 6,000 grams of carbon. So we turn the kilograms into grams there, yeah. Moles of carbon is 6,000 divided by the amount, which is, yeah, okay, yeah, And the ratio is 1:1, so we need to find the mass of 500 moles of carbon dioxide. Mass of 500 moles of carbon dioxide produced when 500 moles of carbon are burned. So 12, that's oxygen, yeah, so 12 plus 32 is 44, okay. So we're trying to find the MR of carbon dioxide, okay, yeah. So that's 44, so that'll be 5. We need to do, because we want to find a mass, 500 divided by 44. No, the other way around. 44 divided by 500, right? No! 44 times 500. Yeah, okay, yeah. So moles, okay, yeah. So the mass is moles times, alright, and the moles is obviously 500. So we do 500 times 44, and that is 2,022. But if you want to convert. So we need the amount of mass, which means mass is moles times MR. 54 grams of water, H2O, was produced when a sample. Okay, so let's find H2O. H2O is 1, 12, 24, 25. No. Yeah. We know. 2, 18. So 18, so 50. Hold on. Okay. So, water, 54, divided by 18, because I don't bloody know, okay? So we're going to use a calculator again. 54 divided by 10. 3! Okay, so we got 3. So 3 moles in water. 3 moles in water. What mass of... Okay. So then 1 to 1, we're going to assume. So methane. What was methane again? Wasn't that CaCO3 something? No, CH4. Okay. That's fine. So carbon is 12. 16. Okay, so we've got 3 moles in that. 16 gram. No, MR. 3 times 16. 48. Okay, why is it half? Oh, it's got the ratio wrong. Oh my god. How would we know the ratio? Insane, don't try me out again. Right. Okay, I don't know what I'm doing. 24 grams of methane were burned in an excess of where? What mass of water would be produced in the reaction, assuming complete combustion? Use the information below to answer the question. Okay, so we got. So we need to find the mass of water. So methane is that. Okay, yeah, okay. Alright, we can do this. 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 So the ratio is 1 to 2. 1 to 2. Okay, yeah. Okay, yeah. Okay. So 1 to 2. 1 to 2. 1 to 2. So we need times by 2 at the end. Okay. I think that's what we need to do. I hope. I pray. Okay. So 24 grams. We need to find the moles. So 24 times by 16 is, I don't know again. So we need a calculator. No, 24 divided by 16, right? Yeah, 24 divided by 16. I hope so. Yeah. Okay, 1.5. So we got 1.5, but now we times by 2 to get 3. So now we have 3 in this situation. Okay, 3. So then 3 of this. We have 3 moles of that, but if we want to find the grams of that, we're gonna have to find out. Okay, so H2O is 18, right? Yep, 18. So 18 divided by 3. No, 3 divided by 18, right? Yeah, 3 divided by 18. And 3 divided by 18 is... Right, we did something wrong. Maybe it's 1 to 1. Okay, so if we're doing the context of 1.5, that's still not right. Hold on. By 18. I'm gonna go with it. 0.16. Ah! Sorry. So it's 1 to 2. Okay, we got the ratio. Okay, we got the ratio right. But did we get the moles right? Yeah, we got 1.5. So the ratio, yeah, is 1 to 2. So 1 mole of methane. What? Ow. Oh! Oh my god. So you don't include the decimal, do you not? When did we do that? Okay, so 3. Okay, no, never mind. I want your horses. We divided it again, didn't we? We divided it again. How do we do Guys, I think we can do it again. We'll real quickly. Okay, so 54 grams. Okay, yeah. So water. Where's water? That. Okay. What mass of methane, yeah, is 54 grams. Okay, so 18 times, no, 54 divided by 18, 54 divided by 8. Oh, no, that's 3. We've already figured that out earlier. So 3 moles in there, 1.5 in there, that means. Okay, so 1.5 times by 1.5 times 16. 1.5 times 16. I'm pretty sure that's 24. 1.5 times 16. 1.5 times 16. I'm pretty sure that's 24, yes. So is that it? 24. Okay. First one right. Okay, we got this. Mole. Yeah. Okay. Look out. Okay, 1. Oh, for God's sake. Right. Let's read the question first. Exactly. Sodium hydroxide reacts with excess. Okay, we did this. I think we got this right last time. Okay, so sodium hydroxide reacts with excess hydrochloric acid. Okay, so what we need to find out is the symbol of hydrochloric acid. Hydrochloric acid, which I think is H something C. No, HCl. What is Cl? 35.5, 36.5, yeah, 36.5 of that. So hydrochloric acid is 36.5 grams. Ooh. Ah. We're trying to find a mass. The mass of sodium hydroxide. How much moles? Okay, we need to find out how much moles. So, what does that say? 36.5. Okay, 36.5. 36.5. What? No, we're doing something wrong here. We don't have the moles or the mass of the hydrochloric acid, so we can't do that. Sodium chloride. We could try sodium chloride first. Yeah, we should try sodium chloride. Oh! Yeah, we'll try sodium chloride first. Smart. Sodium chloride. Sodium 23. Chloride 35.5. 58.5. So 58.5. Are we timesing or dividing? I think we're dividing. 58.5. No, something divided by that. 58 point. Okay. Woo! 100. Oh, that's it. 117 point what? No, it's just 117. Divided by 58. Yeah. Hold on, guys. What? Yeah. I have keys. One sec, guys. Psych. Right, back there we go. Okay, so we've got 2 moles from somewhere. Okay, from that. Sodium hydroxide, that means sodium hydroxide. Sodium hydroxide. Okay. So sodium 23, 16. Is there any like no? So sodium 23, oxygen 16 or 39. Yeah, 39, and then okay, so we've got 40 of that. 40. Oh, is that it? Oh, we didn't do the part 2 because we got the. Oh, I have got 2. we didn't even. Oh my god. Oh my god. When I say we, it's me. Right, hide the score. I don't want to see the score. Hide the links. We've got the link right here, but it's not helping. Just able to work out the mass in math. Okay, you have to work out the mass in grams of 1 mole. It's called 1. 1. I thought the mass. Okay, container hold. 4 grams, how many moles? Okay, you may want to need to. Let's move. Right. Okay, 4 grams, please. Okay, hydrogen gas. Hydrogen gas, hydrogen gas, hydrogen gas, hydrogen gas. Hydrogen gas. Is it just H? Oh no, it's H2. Okay, H2. So 2. So there's 2. 4 divided by 2. 2. 2. Yeah, let's go. Okay, so 100 grams of calcium carbonate was heated until it decomposed to give calcium oxide and carbon dioxide. 56 grams of calcium oxide was left. Work out the mass of carbon dioxide given off. Okay. So carbon dioxide, listen here, I love you, mate. I literally have you right now off the carbon. Alright, so 56 grams of. Okay. 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 So what we need is to find that. So 100 grams. That means that divided by what's calcium? Calcium. So calcium's. That's chlorine. Wait, what's the mass of calcium? No, the atomic mass. Calcium 40. Okay, so that means. I forgot about my brain's not working. Calcium carbonate. What's the symbol for calcium carbonate? Calcium carbonate. Okay, so we need a 3 at the end. Okay, so calcium. Don't know what that was. Calcium is 40 plus C, that's 52, and then 84, right? C's 12, right? Yeah, I'm right about that. Sorry, I'm right about that. So, why am I back on here? Right. So, yeah. 40, 52. Oh, 100. We know. So it's just 1 mole there. Wait a minute. Who are you? Wait, would you just take away them? So it'd be 42. Why would it be 44, gang? 100. 100. 100. Oh my god. Oh my god! I've just took it away wrong. I've just took it away wrong. Okay. I've just took it away wrong. And they shall be 1.5. No, 1.5. No. Oh, we're gonna put 1.5! Jesus. So the avocado. Yeah, I knew that one. Oh my god. I've got to write a balance equation. Let's go, I guess. How is that unbalanced? Okay, so you put 2. I remember this. 2 Na plus 2 H2O. Okay, I got this. Okay, so sodium. Okay, sodium. Okay, I'm going crazy. I'm sorry. So Na. What's Na? There. Okay, so 23 of sodium. 23 of sodium. So 23 times 2, 46. Okay, so I've got 46 sodium. 46 grams. So now we need that to take away. Not 46 grams. 46 of atomic mass. So 46. Oh my god. You gotta be so egotistic, don't you? So egotistic. 2. No, oh, mass. I don't know. With a cannonball. 24 of methane. Water. Okay. We can do this. So what does it want? Mass. So it wants mass. Moles divided by MR. And it wants us to use the information. Okay, so let's find water. So water. Okay, we need something. Okay, so methane. Okay, we'll do methane. So C16. Okay, yes, okay, so 24 divided by 16, yeah. Okay, that's 1.5. So 1.5 moles. Times by 2, 3. Okay, so 3. Okay, here it is. H2O is 218. 18 divided by. No. Times. BAM! Solution of sodium hydroxide was titrated against a solution of sulfuric acid. How many moles of sodium hydroxide would react with 1 mole of sulfuric acid? Hint, it may help to write out a balanced symbol equation for the reaction. The chemical formulas of the acid and alkali are shown below. Right, I don't know why I'm laughing. Okay, so how many moles of sodium hydroxide? Okay, so 1. Same. Okay, what the hell? Get angry. Oh. Remember that one in my head. Anything you said right up in my head. Okay, what's the magazine? Okay, so when 24 is heated in the air, okay, so it's produced. Okay, so it's saying. Okay, I get you. So what mass of magnesium will be needed in order to produce 10 grams of magnesium oxide? 10 grams of magnesium oxide. So we just divide by. I see where you're going. I see. Sorry, what was that? Okay, oh yeah, I remember this one. 6,000. You have to convert it. I hate that you have to convert it. What? 6,000. What mass of carbon dioxide will produce? So 6,000 random moles. 6,000 divided by. Divided by 12. What's that? Oh no, 50. There's 50 moles in there. 50 moles in there, you get me. Okay. What mass of carbon dioxide will be produced? Okay, so there's 50 moles in there, and carbon dioxide there'll be still. It'll be 1 to 1. Okay, so then we've got 50 moles. We've got to do mass times MR. No. Moles times MR. And carbon dioxide is 34. No, idiots. 44. So 44. Oh, 50 divided by 44. I don't know what that is. 50 divided by 44. That does not look right at all. Oh. Still doesn't look right. Hold on a minute. I probably should have something to write this down. Notepad. Right. So, we've actually got 6,000 grams of carbon, but we need to find the amount of moles for that. So, moles is obviously mass divide MR, and the MR of carbon is 12. So we got 6,067, sorry, divide 12 equals 50. So 50 carrying on to that, if we've got the amount of moles we need to do, if we want to find the mass, 50 times what? Oh yeah, sorry, 44. Shit, bro, where's his music at, bro? Music will help me concentrate. Hold on. Alright. Okay, so what have we got so far? Yeah, so, okay, so we want to do that. So, 50 times 44. Oh! Sorry. Divided it too much. Let's put that on charge actually now I think about it. Same. Calcium carbonate. Wait, how much is in calcium? Okay, Ca. Okay, Ca 40. 52. It's 100. 50. Watch how good this is going to be. Ready, go. Quick and easy! How many moles to write a balanced symbol equation for the reaction? I don't know. I don't know, 2. Oh, it's gonna be 1, of course. Same. What's this? Wait, hold on. A solution of sodium hydroxide was added to a solution of sulfuric acid. How many moles of sodium hydroxide would react with 1 mole? Okay, hint. It may help you to write out. Oh my god, I don't want 2! Let's go. Skip it. How many moles of potato would react with? I don't know. 2. Oh, that's 1 this time. Oh. It's just about playing the game, isn't it? Okay, sodium hydroxide, okay. Okay, so we want 50 grams of sodium sulfate. What is what's the thing for sodium sulfate? Yeah, okay, so Na. Sodium sulfate, sodium sulfate. 46. Okay, yeah, 46, 46, 46, 46. 46, hold on. 46 plus 48. 104. 104. And we want 50 divided by 104 then, right? Let's go. I don't think that's the right answer, but I don't know how many grams do they want. I don't know, 48. I don't really know. Oh, 28.2, let's go. I think it's gonna be the same. Let's go. We're so good at this. Let's hit the broken mouth. Oh. Let's go. Let's hit a bit of bow. Get a bit of bow. Oh, how much moles do you think you want? 3. I don't know. Oh, we could have done that ourselves. I think they're the same. Let's probably go. What the hell? Oh, I forgot about that. I think this is going to be. I don't know. I don't know. Wait, we had something about this. Okay, listen here. So I don't really know when I hit the throw. I think that maybe, I don't know, maybe it is 2. Oh, that's not a number, of course, I get ya. Don't really know, why would it be 12? 1 mole of carbon has a mass of 12, I forgot about that. I can't be bothered to read all this. So helpful. Can't be bothered, you get me. It's higher. Oh, it's higher! Okay, we'll do that. We'll leave it at that. It's educate done. I need to do some flashcards now, so you guys are still gonna be looking at me doing this stuff. But you need to be in a different position. We need some different positioning. So in other words, we need you. This is I'll just turn it off. Awesome. Great way to start 2026. Put it in your pocket. Oh, I've turned it off again. There we go. You should be able to see the. There we go. There's a big wiring way, but we can fix that. We can actually fix that by doing that. There we go. Okay, so yeah, for this part, I need you to see this. I kinda need you to see this. So, we need flashcards. Let's go. I've got flashcards over here. Okay. So first, actually no, first, let me make this full screen for you guys. Sorry about that. There we go. Oh, sorry, it's twisted. There we go. I don't know how well you can see what that says. I'll have to tap on the screen. Sorry guys, I don't really know how well you can read that. But it's okay, I'll tell you anyway. So, what is a non-specific defense example? But it says give 5. So I don't know why I've done that, but I think I know this one. So what we're gonna do is, I'm gonna have to zoom out a bit. We're gonna put, I'm gonna have to put it like that, aren't I? Yeah, I'm gonna have to put it to the screen. Yeah, I'm gonna have to do that. Yeah. Okay. So what is a non-specific defense example? I've got 5: skin, nose, stomach, bronchi, and trachea. Let's see if that's right. So we've got the skin, nose, stomach, trachea, and bronchi. Okay. So now that's right. I'm gonna put that over there. All right, and then let's do this. What are protists? No, I don't really remember this one. Let me see if I can think. Damn. I think it's something to do with eukaryotes acting like parasites and then infecting a host. Oh, it actually is. Oh, well, we'll put that in nope, in the correct one because I count that as being correct. Okay. What do measles cause? Food poisoning, right? No! It's always that I get wrong. Sorry, so that goes wrong, so that goes over there. There's also this. What can it cause? Oh! Well, I guess we've got this one, right? What happens when a pathogen gets past our defenses? It can cause disease. So let's go. Right, this one. What are viruses? Well, I classify viruses as small particles that enter our body and produce thousands of new particles. Hey! Let's go. I try to do this every day. Oh, no, just bloody thing. What do protists produce waste that damages our cells and tissues. Nearly turned that over. What is a vector? Oh, I think a vector. I'll do that so you know I'm not looking. I think a vector. Oh, hold on. I've got somewhere. An organism that transmits a disease from one organism to another. Okay, I've got the parasite part, but we don't need the parasite part. We're alright. What is a pathogen's life cycle? Infects a host, reproduce, goes a new one. Let's go. Okay, what does that? Food poisoning. Yeah. What are prokaryotes that produce waste called? So we had a little bit of a freeze there. Toxins, yeah, it's toxins. So we had a little bit of a freeze there, my bad. What is malaria? A disease got from a disease caught from a female mosquito that can cause vomiting, diarrhea, or fever. Yeah! Okay, so that is the correct pile. That is the incorrect pile. Okay, let's actually turn this ring light off a bit. Up a bit. What happens if we turn it all off? Okay, no, that is awful. You ain't reading that. No, that's better. Okay, so what are the two defenses? Non-specific and specific. There we go. I don't know why I always say non-specific, but I just don't ask. Memory cells. Yep. What do white blood cells do if you're infected by the same type of pathogen? They produce antibodies for that specific pathogen. Whatever, I count it. What are the symptoms of what? I'm just gonna say vomiting and diarrhea. Yeah, because that's the only other symptoms I think I wrote down. What do viruses do after producing 1,000 new virus particles? They burst a cell so they can infect loads of new ones, right? Yeah, burst open. Yeah, So this is science I need to learn on most. So this is biology. I need to get chemistry done apparently. What do specific defenses involve? Oh, lymphocytes, easy. By the way, guys, this can also help you guys if you are working on like this kind of stuff. What are the 4 groups of pathogens? Bacteria, fungi, protists, bacteria, fungi, viruses. Yeah. Gives person immunity over a specific disease and it injects like a dead cells and like that. Okay, no. Yeah, I can't. No. Okay, communicable. I think that says communicable. I'm looking at OBS, so I can't. Whatever OBS is, I see. What does communicable mean? An organism go from one to another. Yeah. What do toxins damage? Cells and tissues. Yes. Right, this stuff's too easy. How is measles spread? Breathing and coughing, right? Yeah. Look how easy that was, bro. Look how easy that was. How do white blood cells respond? What do they do? They produce antibody for the specific pathogen. Yeah. Okay, is this the last one? It's the last one. What is next in the bodies? Aha! Dead cells are pathogens. This one I got wrong. What did measles cause? I think I know now. I think it's red skin rash and fever. Yeah. Okay, so that is biology. We need to write some new ones now for chemistry. But for that I need my knowledge organizer. But things about the knowledge organizer that shows my school. So I'll just set it up so you don't see the school. So I don't really want you to see the school. And we're going to do chemistry, by the way. We're going to do chemistry. So I'm going to try to get this set up ready so you don't see the school. So let me get studio mode up. Let me turn that off for you for now. Nope. For God's sake. So I'll let you see that for now. But I need to set something up for. I'll let you guys see this. Okay, so biology is done. I need to write some new flashcards, but first I need my knowledge organizer. Hold on. Okay, no, we don't need that. We've done biology already. What's next? Okay, chemistry. Let me make this so you can see it, but don't see it. She better, she knows it. Okay, there we go. Can you guys read that? I don't think you guys can read that. Okay, actually. My keyboard could cover that part, actually. Right. I apologise. I think that is the best I can get it. But I think you can still kind of read it. Yeah, you can still read it. Okay, so obviously you guys know we have just done, this is the biology ones we've just done, and we're going to do the chemistry ones in a different colour. Now luckily my teachers gave me a new pack of flashcards. I already have loads back there, but I may as well just use this now. I want to do chemistry in this nice blue. So that's why I'm going to try open it from the bottom. But I'll be honest, I think we need scissors for this. So I'm just going to go get it from my thing. Hold on. I'll be back. I'm right here. So actually, so I don't know how to wrap it back. Okay. We've got all this. So, ooh, we could do it in green. Let's do it in green. Okay, so yeah, we don't want orange. Orange can be, physics can be orange. I've got another subject I need to study actually as well, so that could be white. But this one can be chemistry. Right, so I've got a pen. Where's my pen gone? I had a pen. I can't have my pencil case, so it's not a big deal, but I should have a pen around here. I can get one of my pencil case, so it's not a big deal at all. There we go. Right, we've got a pen. We've got a pen. But I'm going to write neat so you guys can read it this time. But we've got, well, because we're only... Wait for it. There we go, it's back. So, I'm going to underline key stuff, because I'm a nerd. And that's what I do, that kind of stuff, because I'm a nerd. That's what nerds do. Right, especially in this. Right, so the first thing I'm going to ask about is thermal decompositions. So I'm going to underline that. That's the first thing I'm going to write. So, okay, so obviously the question is going to be, I'm going to try to write neat so you and big so you guys see it. So yeah, you guys can read that. What is thermal decomposition. There, look at that. There you go. That is the question. So let's turn it around and write the answer. It says on here, the right answer is the breaking down of a substance using heat. The breaking down of a substance using heat. Actually, I might have science tomorrow. I know. Oh, I do have science tomorrow. I've got a biology tomorrow actually, so I better get them flashcards revised. So the breaking down of a substance using heat, and I'm going to underline using heat, so hopefully I remember it. So the breaking down of a substance using heat, and I'm going to read it a couple times. What is thermal decomposition? The breaking down of a substance using heat. What is thermal decomposition? The breaking down of a substance using heat. Okay, I think I remember that now. So let's try and do it off memory for now. What is thermal decomposition? The breaking down of a substance using heat. Okay, we're good with that. We're good with that. Right, let's move these flashcards out the way. Move these out the way. Over there. And we'll put these to one side over here. Okay, so that's first one done. But I want the first ones to be at the top. So, yeah. Well, yeah. Actually, no, they're going to have to be at the bottom. Right. Next up, it says about the conservation of mass. Now, so that's what we're going to ask about. What is the conservation? We need to ask about everything, so I know. Of mass? Question mark. Now, let's twist that over. What it says here, it says the conservation of mass is let's get my ruler. The total mass of the reactants must equal the total mass of the products. So the reactants and the products must have the same mass. That's how I'm going to rewrite it so I remember it. See, I'm giving you tips as well. So I'm going to rewrite it so I remember it. I'm going to actually do it without looking. The mass of the reactants and the products must be equal. And let's see if that's right. The mass Okay, no, hold on. Total mass of the reactants must equal the total mass. Yep, that's right. So let's remember. What is the combination of mass? The mass of the reactants must equal the mass of the products. There we go. Look at that. Okay. Okay. So what can we do? Okay, we could do some knowledge, but let's see if this is really needed. A metal carbonate, when heated, will break down to produce a metal. Don't think we really need to know about that. The equations, we ain't gonna remember them. Okay, pin down. Yes, this is what I want to write about. So, mass appears to be lost. Oh, let me use the other side of my ruler actually now I think about it. Mass appears to be lost during reactions. During reactions, yes. During reactions that produce gases. But this is because it's lost to the atmosphere. So, why is mass lost, right? Yeah. Mass lost during reaction. Oh, I just got a WhatsApp notification. Did I? Yeah, I did, my friend. During reactions that produce what again? Mass. Why is mass lost during reactions that produce mass? Oh, yep, sorry, let's cover that. Well, I think it's because, and I'm going to try to do this without looking at that, mass is lost in the atmosphere. I think that's right. Let's see. Mass is lost to the atmosphere. Yes. Why is mass lost during reaction that produce mass? Mass is lost in the atmosphere. Yep. Let's try do it in memory. Why is mass lost during reactions that produce mass? It's lost in the atmosphere. There we go. Easy, easy, easy. We're nearly done with week 1 already. We're nearly done with week 1 and 2. No, week 2 and 3. Sorry. Okay, so this part is about forming metal oxides. Okay, so oxidation. Oh, keywords. We need to know. We need to know about keywords definitely. I'm pretty sure anyway. Oxidation means adding oxygen. See, I never know. I wouldn't have known that. I would have thought it was something to do with oxygens reacting, but no, it's adding oxygen during a reaction. All right, I can remember that now though. Now that I've just read it, I remember it. So oxidation. I'm just gonna put oxidate. I'm just gonna put so we can save some time. Oxidation ? And by the way, every stream we are going to be looking back at these just real quickly. Adding oxygen during a chemical. How do I sound actually? How do I sound? Adding. Oh, it's using my mic. During. Why is it using my mic? Chemical. How do I sound actually? How do I sound? Right, let's mute that now. Filter, no, properties. Let's this microphone, please. Why did it use the other one? How do I sound? Yeah. Okay, yeah, that sounds good. That sounds better. I don't know why I was using my other one. My bad. But yeah, oxidation is adding oxidation is adding oxygen during a chemical reaction. I am going to remember that now. I already know I am. But I am going to read it again just in case. Oxidation. Adding oxygen during a chemical reaction. Yes. See, flashcards are so useful. So, we took a bite. Let's take another bite. Awesome. little snack. Okay, the time is currently 5:38 British time. So, let's keep going. Okay. Let's see if we need to know this knowledge. Oh, we might need to know about that. Sorry, my camera is going to go off on sometimes. I don't know why it does that. Okay, so if a substance like a metal reacts with oxygen, mass will increase. If a substance like a metal reacts, okay. If a metal reacts with a oxygen, what will happen to the mass? And it'll increase. Okay, we need to get a bit of a move. Oh. What a question on that side. Increase. See, it's a bit confusing with this. Right, let's speed up a bit. We don't need any of that. Okay, yeah. Yep. Right. Okay, so yeah, I want to learn about that. I want to know about that. So mass appears to increase during reactions that have gases as reactants. Okay. Why does... So I'm going to have to write quicker now. Mass, because I don't want to take all day. Why does mass increase in reactions that have gases as reactions? That is because gases cannot be weighed on a balance and are present all around us. Gases cannot be weighed on a balance and is present all around us in the atmosphere. Right. Gases do have mass, so I don't know. Okay, we don't need to know about that. Okay. You need to move. Okay, because we are learning about now moles and using moles to balance equations. So a mole, oh my god, PTSD from that bloody homework we just did, is the amount of any substance that contains number of particles. Okay, amount of any substance that contains Avogadro's number of particles. The amount of any substance that contains Avogadro's number of particles. Got it. Excuse me. Mole, question mark. The okay, go look at that again. Amounts of any substance. Okay. The amount of any substance that contains Avogadro's numbers, and that them numbers are 6 times 10^23, right? Oh, 6.02. Sorry, I keep forgetting about the O2. I always forget about the O2. Forget about the oxygen. I'm kidding. Yeah. Right. Okay. What are chemical amounts measured in mass? What are chemical amounts measured in mass? Yes. Let's go. Right. What else do I need to know? The mass of 1 mole of any substance is in grams. Okay. That's something for a knowledge organizer. Knowledge organizer, knowledge workbook. So we don't need that. So for okay, no, we don't need any of that. Equation. Oh yeah, let's do equation. How do you find the amount of moles? I already know this. Moles equals mass divided by the MR. Pretty sure. Yeah. Okay. So find the amount of moles you would. Sorry, I'm not looking. I'm looking. Moles equals mass divided by MR. Let's go. This is gonna get boring, but you know it's revision. We have to do it. We have to do it. We have to do it. We need to know. Let's take another bite then. Maybe that'll help. Okay. I'm ready to go. I'm ready to go. I'm ready to go. Right. No, we don't need that. We don't need that. Reacting masses. Look up it. Molar ratio. Ratio between the amount of in moles of any substance. Okay. Okay. Molar ratio. The amount of moles of any substance in a chemical reaction, right? What? The ratio between the amount in moles of any substance in a chemical reaction. Okay, molar ratio is the amount of... I've already forgot, bro. The amount of moles in any substance... No. Ratio between the amount of... Okay. It's the rate... Okay, molar ratio is the ratio of the amount of moles in any substance in a chemical reaction. Molar ratio. The ratio between the amount of moles in moles of any substances. Top of my pen. In any chemical reaction. Damn, my hand's getting tired. We'll do chemistry and we'll be done. We'll have to go over them again. Right, let's finish this. Finish this biscuit. Done. Right. Okay, let's go. Let's move on to this. Which means I kind of want you to move over there. Awesome. Awesome stuff. Right, so. The concentration of solutions. So that's awful underlining. I'm going to move it a bit like that. Okay, so. Vocabulary. Okay, a solid substance. Okay. What is a solid substance that holds in a liquid cold? Okay, a solid substance that holds in a liquid cold. A solid substance that dissolves in a liquid is called solvent. Let's do this thing, right? A solid substance that dissolves in a liquid is called solute. And the two, when mixed together, okay, no, I can't really write that now. Too late. Okay, what does concentration refer to? And the concentration refers to the amount of solute, right? Yeah, the amount of solvent there is in a specific type of solvent. Okay. The amount of solute there is in a specific volume of solvent. Okay. The amount of solute in a specific volume of solvent. So the amount of solute there is in a specific volume. Yeah. That's good enough. Read that again. Refers to the amount of solute there is specific to the volume of a solvent. Yeah. Awesome stuff. So, okay, so we've done that. So we can go bop. Okay, we've nearly done with chemistry. Jesus Christ, this is tiring. The greater the amount of solute in a given volume, the greater condensation. Oh! The greater the amount of solute in a given volume, the greater the concentration. Okay, I'm gonna do equals Let's go. We're nearly done. Come on. Okay, we've done that. Calculating concentration. Okay, fine. Using the following expression: mass of solute. Oh, yeah. Let's write that equation down. Equation for concentration. Okay. Solute mass divided by volume equals concentration. Let's go. Skibbity. Okay, we're actually making our way through this pretty quick. Volume in chemistry is measured in decimeters cubes. You may be asked to convert cm3 and to do is simply divide. Oh. To convert to cm3 to dm3, what do you divide by? And that would be 1,000. You would divide by 1,000 to get dm3. Awesome stuff. Okay, we're down here now. We're actually pretty down, so which means I need to move this. Okay, I'll have to zoom out actually. There we are. Okay, so student dissolved. Okay, no, we don't need that. Oh no. Oh yeah, let's say solve this. A student dissolved 10 grams of sodium, what does that say? Hydroxide NaOH in 2 decimeters cubed of distilled water. Okay, now this is the important part. Calculate the concentration. Now, I know what we would do. I know exactly what we would do. No, I know exactly what we would do. So, this is the mass. We would just divide that by that. Which, the concentration would be 5 grams decimal meters cubed. And it should tell us... Is that it? Yeah! Let's go! Okay, so that's chemistry done. We still have all these. We could probably use these for physics, actually, but we're not going to do physics right now. Right! Let's see if we remember all of those that we've done so far. Okay, let's put all these flashcards that we ain't used yet. Like, I've got loads of flashcards right now, so I'm fine for now. Let's get this. Flashcards, I love flashcards. Okay, so we've got this. We've got our chemistry. Let's mix them up a bit. Let's get some of them in there. Some of these up here. And there we go. Okay, let's see how much we get right. Let's move this. Let's see how much we get right. Okay. So this is correct. So tick, cross. Tick. Okay, let's zoom in a bit. Let's do it like that. Oh, wire. Bye. Okay. What is a non-specific defense example? Give 5. That was the easiest. Skin, nose, stomach, bronchi, trachea. Yeah. Correct. What are protists? Oh no, I can do this. Eukaryotes that acts like parasites and then affect the host. Yes. Let's do this. Measles cause. What do measles cause? Red skin rash and fever. Yes. Look at us. What's injected into the body? Excuse me. A small amount of dead or inactive cells. Or pathogens. I count it. What do white blood cells... How do white blood cells respond? What do? They produce antibodies for the specific pathogen. How is measles spread? Breathing and coughing. Concentration refers to... Oh. These ones I might not remember. The amount... Okay, concentration refers to the amount of solute in a specific volume of solvent. Oh, no way, I just got that. The solid substance that dissolves in a liquid is called a solvent. Crap. Yeah, that's our first one wrong. Molar ratio. The ratio between... okay, the ratio... Hold on. The ratio between the moles of any substance in a chemical reaction. Alright, I count it. How do you find the amount of moles? You do mass divided by MR. Yep. What are chemical measuring? Mass. What is a mole? I don't know that one. The amount of any substance that contains the amount of any substance that contains that. Yeah, of course. Why does mass increase in reactions that have gases or as reactions? Because you can't weigh gas on a balance, and it's present all around us. Yeah. Okay, I'm getting good. If a metal reacts with an oxygen, what will happen to the mass? It will increase. Yeah. Oxidation is adding oxygen to a chemical reaction. Yes, yeah, that's the one I remember. Why is mass lost during a reaction that produces mass? Because it gets lost into the atmosphere. Let's go speed run. The conversation on mass is that the mass of the products and the mass of the reactant that have to be equal. Yeah. What do toxins damage cells and tissues? Yes. These I might forget these actually. Hold on. These I might actually forget. What does communicable mean? An organism that can be spread from one organism to another. Yes. Definition of vaccination gives a person immunity over a pathogen or a disease. No, a disease or parasite without being infected or survive first. Yeah. What are 4 groups of pathogens? Bacteria, fungi, protists, virus. Yeah. What are specific defenses involve? Lymphocytes. These are getting easy now, these biology. What do viruses do after producing thousands of new virus particles? Burst a cell so they can infect more. Yeah. What are symptoms? Vomiting and diarrhea. What do white blood cells do if you're infected by the same type of pathogen? They react quickly by producing antibodies. What stays in the body? Memory cells. What are the 2 defenses that humans have? Non-specific and specific. I always say non-specific, I don't know why. What is malaria? A disease transmitted by a female mosquito that causes fever, vomiting, diarrhea. Yeah. What are prokaryotes that produce waste called toxins? What does salmonella cause? Food poisoning. What is a pathogen's lifestyle? They infect a host, reproduce or replicate, and infect a new one. What's a vector? This one I forgot. An organism that transmits a disease parasite from one organism to another. Yeah. What do protists produce? Ooh. Waste that damage cells and tissues. Okay. What are viruses? Small particles that enter our body and produces thousands of new particles. Yeah. Okay. That one I struggle on all the time. What happens if a pathogen gets past our defenses? It can cause disease. Yeah, sorry. I don't know how to go out. Thermal decomposition is to break it down of a substance using heat. Assume it dissolved 5 grams per decimal meter cubed. Yeah. To convert centimeters cubed to decimeter cubed, what do you divide by 1,000? Yeah. Equation for concentration. Oh, I forgot that one. The solute mass divided by volume. Yes, I'm still on top of it. The greater the amount of solute in a given volume, the greater the amount of concentration. Right, we've got 2 wrong here. A mole is any substance that contains Avogadro's number. Let's go. A solid substance that dissolves in a liquid is called a solute. Yes, right. Chemistry and biology, we are done. With flashcards, at least. Okay. Jesus, that was tiring. Right, so and I need to get all these done before end of half term, which is next week, which is the end of this week. So I think tomorrow we're gonna have to try to do 2 subjects. But we've done all our homework, we've done all the revision. I think we've done all that. It's alright. Everything can be... Right, let's put... I'm going to put all these back now. Hold on, guys. All these flashcards can go in my little backpack. Hold on. And I can use them. I can use them to revise, like every day, every morning, every night. That's what's going to happen. And when I get home, okay, straight away I wake up before I go to school. When I come back from school, and at night, that's how much I'll revise them, because that's how much I want to stay on top of it. That's how serious I am. That's how serious I am. And that's literally just revision. Then I've got to do that for every term. If anything, I'll have to create my own flashcards if needs be. So, okay, after flashcards stuff done, and there's probably still flashcards lying around somewhere, to be honest. Right, I need to clean a lot of stuff up though, because like my thing is so messy now. But let me put you back to where you need to be. Hold on, you can go out of there now. Right. Let me put you there. Hold on. Oh, you're a bit low. There we go. Well, I think that might sum it up for the stream. I don't think there's anything else we need to do on the stream. I don't think there is anything else we need to do on the stream. I don't think there is anything else. And I forgot what I've got to do now. I think I've got to do something. Oh yeah, I've got to turn Kayla's stream into a video, I think. But I kind of still want to stream, you know. I do really want to stream still. Like I really want to stream still. But I don't think I have to. I think I need to take a break. Oh no, that really reduces the quality, doesn't it? So we're not going to do that. Do you guys want to play? I mean, I'll play some Still a Brain Rot. I'll say you guys, but no one's here right now. Let me flip that again like that. Nope, not like that. Like no, not like that. Like that. There we go. Right. I'm gonna load up Still a Brain Rot for you guys, because I know you guys probably really want me to play Still a Brain Rot. Right. Let me I don't want to play. Right, leave that going. Oh no, it turns off when I do that, doesn't it? Forgot about that. So we're gonna play Still Brain Rot. I'm gonna play some Nights in the Forest. We can delete all this now. I miss music, man. Make me feel a certain way. Right. What was I gonna do now? Oh yeah, change the name of the stream. Playing Roblox. Come join. Smiley face. Oh god. Right, we still need my Bombarghini Cusino. I could put on like my story or something. I haven't got a Bombarghini Cusino. Well, my Snapchat story, but no. If I say that, then what if one spawns? I think we need that for one of them actually. But that spawns a lot actually, so. I ain't too worried about that. When that's been happening, 50 minutes. It is a mythic and it's 12 minutes until the next mythic spawn, so I hope the mythics are Bombardini Cosini. You get me? Let's go get it playing again. Oh yeah, oh mythic. I want good brain rolls now. How much have these been generated? Oh, get them told. Oh yeah, these guys are gonna generate loads now. Oh, Ragantini could see. Oh yeah, you come when I need you, but I only found you yesterday. Didn't I? After ages looking for you. Took me ages to find you. Yeah, I know. I just realised you can't see me. Sorry. Sorry, I was just shouting at her. Brain rot. It wasn't a big a deal anyway. We'll turn it down a bit. Not a big deal. We want. All you could see is what you missed out was me shouting at her brain rot. Really. Kind of all you missed out on. It's not too bad. Yeah, I'm just looking at something. Right, I've finished now, guys. I'll let you guys see now. There you go. I need a puppy, need gonna see me now. I need a bummer, need gonna see me now. I don't care how long it takes. I just need a bummer, gonna see me right now, eh? Let's go. Yeah. Oh. Yo. Come on, please, yeah, come on. Oh, I don't know how to go, I don't know where to go, bro. I don't know. I swear to God, this Bummergini Gusini just spawned right now. I really need that Bummergini Gusini right bloody now. I'm telling you, I need this right now. I'm telling you, I need this right now. Please, come on and bring it to me right bloody now. I swear to God, if you don't bring it right now, I'm gonna go and I'm gonna scream and shout, rah! Oh! Ooh. Can you come out, yeah? But instead of a crocodile, a Gusini. Yeah. I get you. I think we understand each other, Bombadillo, crocodile. Oh, another Bombadillo crocodile spawn. I don't want a crocodile, okay? I need a Gusini. A Cugini. Do you know what that is, bro? If you know what that is, bro, can you please tell him to come out here, please? Ooh, I like this music. It's me, yeah, oh my God, I'm feeling the beat, oh yeah, feeling this heat. Don't talk to me, ain't I'm gonna hit him with the heat. I don't know what I gotta. Yeah, I'm gonna hit you with my penis. What? I don't know what I'm on about. It's very hairy down there. I need to stop talking about hairy penis. You get me? I don't know what I'm doing no more. I'm just hitting the flow. Oh, I don't really know. I don't know where to go. I think Michael Pinkerton is very here. I don't know if Edward House is really that friendly. I don't know. He kinda just left us in the library yesterday. I don't know. He never really came back. I don't know if he would just really read it out because he didn't like to sit in the library. But I'm just rapping about random school drama because I'm really bored and I came really bored, bruh. I don't know, I'm just trying to rap. I don't know what to rap, I don't know what to crap, I don't know. I don't bloody wanna scrap, alright? I don't wanna scrap. Yeah. I don't wanna scrap. Yeah. I don't wanna scrap. Yeah, I'm just gonna leave Field Brown now. I'm bored of Field Brown. Let's hop on some 99 Nights in the Forest, which means we need to get different music on. Where's my eyebrow? Dark. Not dark. Sure. I need to try to get day 99 one of these days. What I need is a bunny foot, but I want to level up 5 first. I might have to see my sister if she wants to join in again. Bunny foot, yay. First try. Awesome. That shows good luck's gonna come my way. Let's go, come on. I mean, we could try to get level 3. I don't think that's really worth it. Actually, it might be. Actually, no, there's a house where there's chairs in and we can put them in a fire. But I'm thinking maybe instead of the fire, we put that in the table. You know what I'm trying to say? I know I'm using a flashlight in the light. Don't judge me. I'm just trying to find this house. Don't really want to scrap your mind now, mate. Oh, there's a flute here. Let's go. Skip it there. Where's this house, bro? Do we need to unlock another level? I think we might need to unlock another level. Because this house... Whenever we unlock this house... Oh. Whenever we unlock this house, it has like loads of levels. Yeah, that's really not. Let's put that. Come on. Yeah, I know. I see. The pelt trader comes tomorrow though, I think, so we can get better stuff. When we get a wolf pelt, so actually while I'm on it. Maybe we should upgrade a fire though, so we can find like chests. Oh, there's a chest up there actually. Yeah, we'll go up there. I said there will be chests up there. Right, let's eat a carrot. Actually, no, we'll eat a pumpkin. And let's go up this ladder. Okay, let's see what this is. Bucket seeds. Kinda need to find some chests and stuff. Pop a mint fam. Need a candle for that. What a mate. Do with it. Could do with a wolf pelt actually now I think about it. Got a wolf pelt on you? Nope, of course you don't. Is there another wolf around? There is. Come here, mate. Come on. Come on, I'll help you. It's an OP way of killing them, guys. Another wolf around, please. I need a wolf pelt. Oh, okay, I'm really low on health. I don't really feel like dying this early. Oh. Well, let's go back to the campfire. Is that guy still peeking? We'll get wolves in the morning. There he is. Do we get a good sack? Yeah, I think we get a good sack. No, good axe. We need to kill those wolves. Where are these pesky wolves? I need a wolf pelt. I need a good sack as well. Hey, wolf there! You do wolf, come here. Come here. Yeah. Oh yes! Get in there. Yeah, I'll bring food with me. Let's go, let's go. Ooh. What else do you want? Alpha wolf, don't it? You want alpha wolf? See if we can get him alpha wolf in time. We might not be able to. Because getting a spear or a revolver or whatever I want. Either one will be very useful. Let me see if there's alpha wolves in this. No, they're not alpha wolves. The fact that there's cult members makes me have hope that there's alpha wolves. And I say hope because I don't know for sure. What's after me? Oh, you. You're after me. Come on, is there no alpha wolves? No alpha wolves, man? You kidding me? So, I've got about 600 million wolves on me. No alpha wolves at all. No? Nothing at all. Right then. Guess let's go back to the fire. We do need to get a bed, but we need to also get that kid. That's why I wanted the alpha wolf. I guess we'll have to try and find one in a chest or something. What we need is 20 wood. Okay, we made some progress. Ooh, we should tame some wolves actually. I better not play this music for the whole time. Oh yeah. I'll say I better not play that for the whole bloody time. I'm just trying to get enough steak as well for get wolf, which is why we need to kill 2 wolves. Our fire's doing fine. Oh, actually no, should we go get the kid? I think we go get the kid actually, now I think about it. Yeah, let's go get the kid, we can get steak from there. Perfect plan. Perfect plan. Come here, twat. Okay, I'm low. I'm low. Let's heal. Let's give myself time to heal. And let's collect some steak actually while we're here. We can claim a wolf. The question is, should we? We're going to get a little bit more health till we go for the last two. I think there's only 2 left. No, there's 3. Okay. Okay, we need... Well, when we get all these, we can get, yeah, we need 3 more steak anyway, so... Should have put that in my sack. Come on. Oh, I gotta click it. Right, tomorrow, in game tomorrow, we'll get some Oh, is it okay with? Do they still like cooked morsel? I guess we'll see. I should have 6, okay, 2. 3, 4, okay, there we go. I just kind of hope they still like cooked. I don't really know. I guess this is how we test it out. Then we need to get out of bed. You know. 1 bolt. Oh, should have ate that. Whatever. You know what? We'll just use the raw stuff for now. Let's put that in my bag. From the revision. Come on, boy, let's do this. Let's pick up. And we'll go for that rabbit. Oh, actually, is poultry gonna come today, actually? I don't think so. If he comes today, we'll upgrade the fire and get an alpha. No. Actually, after we get this wolf, we'll Okay, we got our first dog. I don't want to risk using. Let's sit him down. Where did that rabbit go? Oh, there you are. One. Two. Oh, yes! Get in there. Okay, we've got 3 morsels now. Now we need 3 steak. Right, means we've got to kill 3 wolves. But have we got a spear? We'll tame it. We'll tame it tomorrow, though. Then they can follow us all around. 29, 8, steak. Okay, we might need to get another morsel tomorrow. Over there, mate. Okay, we do need one more morsel, but I don't think there's a rabbit in sight. Okay, there's one over there, but I don't want to get tapped, so. We'll wait until morning, which is 30 seconds, which is not even too bad. Hey, kid. We need to get another kid as well, actually. So, oh, maybe we get that other kid tomorrow. Oh, yeah, because they could give us an alpha wolf pelt, actually. Genius. That's genius. That's actually so genius. That's actually so smart. But let's restock on this a bit, and then we'll go. We need to buy a compass, actually, for that. Oh, I don't think we have enough for a compass. Nope. We do not. Do we have any like... Oh, saviour. Saviour. Absolute saviour. Right. Cracking kid, come on. To be fair, we probably should just keep... oh, crap. Right, I'll keep that going for a bit. Let's go get this alpha stuff. Oh yeah, he's here today. Let's do this thing, come on. And let's pick these flowers. Oh, we do have a Halloween candle. My days. Oh, they all come for me, are they? Where's the rest of you? Over the hill? Yeah, you're not one. Where are the rest of them? Where's the rest of them, bro? Actually, let's kill some of these. Do you have alpha wolf pelt for me? No, they don't. Crap. Where's the rest of them, though? Where do the rest of them be? Oh, we could tame a alpha wolf. That could be cool, but they probably need a lot of stuff. Yeah, they will need a lot of stuff. I'm gonna heal. Where's... No, I don't want to fight you. Crap, crap, crap. Everything wants to kill me right now. We'll have to do it tomorrow. Sorry, I haven't really been speaking, have I? Right. Well, there's an owl. There's an owl fucker. What's that? Kind of neaten up my desk a little bit. Hey, Biscuit. Yeah, you can protect me, Biscuit. That reminds me of a dead hamster. Damano. Dama. Dama. What is that? Oh. What is that? Is that Roblox? No. I don't know what that is. There we go, we go try again. Dragon, come on, try again. No, where are the blue colours though? They all just gone away. Maybe I'll just try to kill all of them here. Yeah, boy. You wanna go, boy? You're dead. You're dead. Oh, there's only one more left. Where is this last wolf? Am I stupid? Oi, where's your friend? Yeah, you. Where's your bloody friend? Show me where your friend is. I need your friend. Oh, that's good. It's good and all. I hear him. Oh, he's trapped in. I need to upgrade my fire, don't I? I bet you. I bet you. I bet you he wants me to upgrade my fire. Come on. We need to get this kid. But we did get an alpha wolf pelt, which is good. Yeah, level up our fight before we go back there now. Oh. I realised my webcam's not here. There we go. Back. I don't know what happened there. I don't know why I keep doing that. Okay, we have upgraded our thing a bit though. What do we have in here? Can we make? Should we make a wood rain storage? Or can't we make that yet? Can we? Do we need that for that? Oh no, we can. But no, we can't because we don't have enough bolts. One more bolt. 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 All we need. It's not one bolt anyway. Is that a bolt? That's where we can source a lot of wood. Probably just get another one as well. Maybe we should work our base for a bit right now. Yeah, let's work on our base for a bit right now. Let's get our base sorted. Let's get like 5 wood drain storages and fill it up with wood. And then let's fill this first one up first. Because we need to level up this 5 before we can even go get the kid anyway. We need to break 5 trees. Right, let's put all this in the wood drain storage. You never know when it'll start raining. Any more trees? Oh, candle. No, actually no, because if I get tricked, that's bad for me. So no, what I need right now is bolts. I need another 5 bolts. That's 1. Three. Back off, wolf. Well, yeah. You little crap. Coal, take it. What's in here? Let's go. Come on, away. 4. Oh yeah, food. And 5, 6. We do need food. Let's make our way back. See if we can get a pumpkin on the way back. I don't think so. Oh, there's a sneaky little pumpkin over there. Do we risk it? Yeah, risk it. Go for it. Right, let's put some of this. Yeah, I want to get this upgraded by tomorrow. Tomorrow I want this to be level 5. That's the goal. Ugh. That's the goal. Oh yeah, sorry, you can stand on that biscuit if you want. Follow me. Alright. May as well cook these, I don't think I'm gonna get another dog. Hey, biscuit. We need to get more wood. I'll tell you that, we need to get more wood. Definitely. So defo. Big Deborah, shake Deborah, underground at dark. God damn, go. What? Stop doing that noise. Yep, biscuit. How you doing, biscuit? Yeah, good day. Right, let's level up that fire. Is level 5 max level, by the way? I have no idea. Oh, you kidding me? Sorry, we have a wood rain storage for a reason. Peltry was arrived today. Oh. Well, let's go give that alpha wolf pelt to him by the time when we get back, which won't be long. We'll fill up this. They won't attack me if I go. And no, I'm gonna go over here. I don't want to risk them attacking me. Actually, no, I kind of want to go over there now. Whether they have something good. Come on! Come on, lad. Come on, bruv. Come here, bruv. Oh crap, oh crap, oh crap, oh crap, oh crap. Let's go. We have so much ammo for this though. Come on, biscuit. We're off back home. Through a long stressful day. Wait for him told to heal. Damn, that went down pretty fast. Maybe we'll just get some more while that dries. Oh yeah, give this pelt. Yeah, let's get a giant sack. Get as much trees as we can. What? Hold on. My dinner's even ready, bro. Okay. We need this fire upgraded if we want to get this kid. Give me it. Oh my god, I don't have much time. We're gonna get attacked tonight as well. Great. It's wonderful. I kill everything before I bloody go get dinner. Where's the rest? Crossbow, crossbow, here he is. How dare you? How dare you? Right, let me go get my dinner. Jesus Christ. I'll be back, guys. Right, let's pretty level up this fire. Get wood. We've got a giant sack now. Oh. Come on, bro. This should be it, this should be it. Let's go get that kid! Oh, that's yeah. There he is. Crap. Jeez, man. I can't play like this. No, I'm just gonna have to. Oh, let me eat. Alright, let me go up here. Let me just chill while I eat. Let me eat while I chill for the night. I've already created a mess in my bed because for some reason I put it in my bed. I don't know why I did that. I'll put you there for now. Oh, Jesus. Right. Let it out. Jeez, bro. That's crazy. Mum. My mama. This is crazy, bro. Huh? What? Whatever. Oh then. That's how you want to play at Roblox, that's how you do it. We'll do it like that. That's how you bloody want to play it. What the hell? Do you guys want to watch an Oliver and Taylor video? Me and my sister. Well, no one's here really here, so I'll do what I want while I'm over there. Where's Oliver and Taylor? Right, this music can go off now. Let's watch an Oliver and Taylor video. Yeah, my favourite channel. We need to post a new video actually. I'm posting a new video. Excuse me. Let's do. We'll watch this. Sorry, I can't play the intro because it'll get copyrighted. But it's really cool. The intro is really cool, I promise you. My sister said it sounds like a Wednesday soundtrack. I don't see it, but if you guys go listen to it or see it, the intro, we have a separate video where we just posted the intro. There we go. I can play it now. Clary, we fixed Kale's audio now from last episode. So, welcome back to another video. Today, we are playing doors. And Kale, there is a battle mode, by the way, as well, by the way. You want to try this first?
No, I don't want to do that.
Can we do that? Can we do it after? Because I don't know what it is.
I don't know what it is. That's why I don't want to do it.
Battle
What
mode?
do we do?
Battle mode? Okay, fine. We'll just do normal.
No!
We'll do normal.
I'm scared.
Right. Okay. What are you doing?
No.
Why is it saying you're not in?
I'm in. Oh, it's because I'm not playing. How do I do this? What do I do? How do I play?
Oh my days, Kayla. Come in this one. Okay, get out there.
Yeah, but it says start. What am I doing? No.
Oh, go in this one
Press
then.
the play button.
Go in this one. Go in this one. Jesus.
I'm
What
in.
was that? What was that? Yeah, it's working. It's alright now. That was a bit
working.
strange. Let's
Don't
go.
like this game.
You said you wanted to play it.
That's how I'll be fine playing it.
Well, deal with it. Let's go.
Oh yeah, let's go. I forgot you have to be first. If that shush guy comes, I'm gonna smack him in the face.
Oh, he's definitely gonna come, Kayla. Don't worry about that.
Okay, get the key.
Oh crap.
Woo!
I want to hear you scream, Kayla, for the today's video for the clip farming. Ah! I'm kidding. So, alright, Kayla, why are you already not here? Kayla, come on. It's gonna jump scare you, Kayla, if you're not with me. It's gonna jump scare you if you're not with me, so be with me. And I've already opened all them drawers anyway, Kayla, so I don't know why you're looking at them. What the hell was this wardrobe thingy? Kayla, I swear to God, it's gonna leave you if you're not with me. It'll jump scare you and then you'll be like, ah, Oliver jump scared me. I don't like this game no more.
I won't like the game anyway.
Yeah, you probably still don't like the game.
Oh, coins.
Never played still.
The coins are on the floor. What's the point in that? Ah! Ah!
Don't look at him, Kayla, you idiot. Come on then. Yeah, don't look at him, you idiot. Oh, yeah, you're fine now, you're fine. You can look forward now.
Oh, I'm trying to sprint with shift, but it's not working.
Oh yeah, you can't sprint in this game. You gotta deal with how fast you are. Alright! Oh.
7, my lucky number!
What?
7's my lucky number.
I think 10's my lucky number. This is such a random number.
Actually-
You know. Jeez, I walk faster when you're in front of me.
Oh, really?
No. Yeah, of course. Oh, it's new. Oh, I didn't even see this room. What the hell? Who's that? Who's this girl? Kelly, who's this girl? Kelly, tell me, Kelly, do you have a relationship with this girl? Do you have any sort of
Yes.
friendship? Oh, you do. What's her name? What's her name?
She's my girlfriend and her name's Susie.
Susie. Look, nice to meet you. Girlfriend?
Whatever. Let's go.
Yeah. I must be in.
Ah, no, guys. There's nothing wrong with girlfriends. Nothing wrong. Nothing wrong. When you're a boy.
Crazy, Oliver, crazy comment.
Kayla's not actually listening, by the way. I just want to say that. Let's just clarify that.
I'm gay.
Oh, can you just flip me?
She had a boyfriend, yeah. When she was 3, okay. So fine.
I've never had an interest in a boy since.
I don't think that was a proper boyfriend-girlfriend thing. No, you were little.
No, I think he was a boy that was my friend who I called my boyfriend.
Mommy, I got a boyfriend.
I have boys that are my friends now.
Ah! Sky. Oh,
That guy really PMO, bro.
What does that mean?
Under a
Do I
bed.
have to go in the wardrobe?
Yeah. Are you okay? Are you okay?
Can I come out now?
Yeah, you can come out now.
Yeah.
Are you okay?
Yeah, where am I? Where are you?
Nowhere. I'm in your dreams. Ah! Get away, Sky. Okay, where are you? Kayla!
I can't get it. I don't know what I'm doing.
It's alright. Chill. Oh, there you are. Hey,
Where are you? Where? I can't see you.
Kill. Oh, chill. Cat, I'm behind you. Chill. Cat, I'm here. Chill. Ah, this guy.
I was like, look, see you. That was creepy.
Can this guy leave me alone? Honestly.
I don't like this.
That's why we need to be on police voice chat. Oh, we need a key. Sorry, I'll open the door so you can see an open. Oh, it's here. Found it.
Found the door.
Yeah, I found the key. Get out of that hellhole.
Oh, no, this guy.
I got a lot of that sky killer.
Right, to be fair, I'm going to end the stream here, guys, but thank you guys, yeah, for everything. See you later time.